when the people from the RootedCon asked me to prepare a presentation, I didn't know anything about the content of it, and I wasn't very clear about that, about the content of my presentation, and then I just sent out that title. And I was very clear that it was the last talk that I was going to give about safety and security on aviation. It is not that I got tired, it is not that I got threats only. Okay, give me an applause. Thank you very much for helping me out. So the reason is not only that, but also in the last weeks or months, not only my situation with the world of aviation has improved, but I've also started to have symptoms or see symptoms, not only in terms of many changes in aviation, but I believe that things will start changing in the mid-term. Well, the thing about this, talking about aviation security, it was not about coming here and just to feed my ego, but it was just about my concern, the concern that I had. I am a pilot, you know that, and I was really concerned about that safety issues. I just wanted to warn about that. I think I have achieved my objective, and there are good perspectives ahead for midterm changes. Okay, so therefore, the real topic of my presentation is different to that. So today I will be talking about coding your flight simulator. So there is a play on words in English, and it is the last talk that instead of focusing on myself, on my discoveries, I want to focus on you and on your potential. We will look at that in the next slide. Okay, so the second slide is much better than the first one, isn't it? And this is the slide where, that I wanted to show you when I explained why this is the last talk that I give of this kind. And now I'll tell you what I will be discussing with you. We will be talking about exploitation and post-exploitation of aviation systems. So let us go into the technical aspects as to how to find, how to exploit, and how to post-exploit vulnerabilities on flying on aircraft, helicopters, planes, or you could also apply it to other land crafts. Aviation is changing. There are signs for things to be changing soon, but still, aviation is a very closed industry, highly endogamic one, or lots of inbreeding into it. And then, so I will continue to work on these issues privately. And, well, sometimes I suspect whether they will go back to that or not. No, but I think it is good for them to know that even if the door is closed, okay, they need to know that there is always someone like kind of looking to them or paying attention to them. But I need support. I just need other people to replace me. I want to pass on the baton. And if someone is curious about that, I encourage you to do research on this area. You don't really need like a deep knowledge or huge investments. You can start very same afternoon on your way back home. Okay, well, if you are coming back home by plane, I advise you not to do it. But what I mean, okay, you need very short investment, very little investments, and you need minimum requirements. You must have minimum knowledge about exploitation and shell coding, and especially for Windows platforms, NICs and derivatives, and then common platforms, the i368, 64, and ARM. So, well, you know all about that. And then blue. Here I want to offer you resources and help and to share this type of research with you. So this is, well, these resources or this presentation has been thought of as a kind of resource. Every time you see text in this color, in this blue color, it means that this is a link. Okay? Okay, agenda. First of all, we'll talk about that flight simulator that we will be creating, that we will be using for this kind of thing. Second, we will take a look at how we can build our own virtual airline, then how you can create your own virtual aircraft. And then my presentation will be divided into different fields. On one hand, general aviation, like small aircraft. And then, on the other hand, commercial aviation, like bigger plane aircrafts that we use, well, to travel more often, okay? And last, when everything you will be, all of you will be really tired of me, really hungry, you would have eaten up all the buns that I left here in this backpack, then I show you a bonus. We have a bonus, and the bonus will not be included in the presentations that you will be getting later on. So it's up to you whether to stay right until the end or not. Okay, okay. I'll go right into it. We are a bit behind the schedule. So let us see how we can program our flight simulator and what are the characteristics that it should have. I wanted to do a flight simulator, and the big premise of it is that it had to be realistic, extremely realistic, hyper realistic. I really wanted to see how aircrafts were moving in the sky. I wanted it to have a strategy component, so it is not that flying aircraft and taking it off and landing it off, but I wanted to handle the airlines fleet, and then also I wanted it to have a bit of a role side to it so that you could improve your skills, etc. as a pilot. Okay, first of all, how you control, how you build, how you create your own airline. Well, this is basically what we've seen in my two previous presentations. As I told you, actually you don't need any 0-day or no exploits to send out, to receive, and to exchange information with other aircraft or with land stations, etc. And then also the technologies, even if you may use the aviation ones, you can also use like more mundane technologies that you are all used to using, such as web applications, Bluetooth, 3G, 4G, Wi-Fi, etc. Well, we have discussed that in detail in my previous talks, okay? And more links this time as well. Okay, this is for you to set up the strategy side of your flight simulator. Now this is a mini demo. Obviously, well, this is not ready either. Okay. Okay, if I open up a terminal here, okay. Okay, okay, yeah, I can do it. I know I should have gotten this ready beforehand. It was not possible today. Okay, let us do it now. I did my flight simulator in Python. So we take this splash screen here. And well, this is our home screen for our flight simulator. This will require a Wi-Fi connection. I don't have one. Okay, I go back. Okay, I cancel it, and now first of all I see if I can just connect to any Wi-Fi. Layak. Okay, I'm watching you. Okay, my Mac is connecting to the Wi-Fi. It will take a few seconds. Oh no! Exclamation mark. I was not expecting that. I'm afraid I need Wi-Fi connection. Well, there is one, the hotel auditorium, but I don't know whether I trust it or not. Okay, we are back now. Our flight simulator, you can create a new airline or just upload an existing one. Well, all the data that we will be seeing are fake. Okay, do not accuse me of doing any fake, because that is a real fake. I will not be showing you real data from real aircraft. Okay? So the window. Okay, I want to bring it back here. Okay, I cannot maximize it. It's doing its own thing. I cannot minimize it either or reduce the size of it. No, I cannot do it. Well, okay, no problem. I just move windows and that's it. So basically what we have here on the left, we have the different paragraphs, we have sections, we have the dashboard. Here we will take a look at the overview of the world of aviation, competitors, information about my well, aviation world. The second one is about my fleet. Second one is about ratings and flights. Okay, I will discuss that later on. Okay, we uploaded. Okay, we click on it again. You haven't seen what you've seen, remember? Okay, and now loading. We have Spain, we have our Madrid here. And now this is the list of aircraft. These are raw data that are easier to handle. This is a geographical view. If we select an aircraft, these are data for that aircraft. So these are the raw data of that aircraft. We also have a tab to find the aircraft in the local area, but this time we do not have coverage for that. For data link, we have a mini searcher, a mini search window. So imagine that we want to use ARINC. We talked about this company before. Imagine that we want to use ARINC for our communication. Then we find the login web ASD. Web ASD login. Okay, we just connect. We just use our credentials, and that's it. Okay, these are our aircraft, and say Airbus 800 and 320. I always wanted one. Okay, I click on the right button. Okay, I buy it. As I say, this is a fake. We buy it. Okay, that means that we have all the keys that we need because this is fake. Okay, let us do different testing. Okay, see if this one works as well. I want, please. Okay. Okay, and last one, if it doesn't work, okay, we stop here. That means that that aircraft is very expensive, okay, or we just don't have the keys for it. And last, we move on to the fleet. These are our aircraft. So these are the aircraft that we bought, the ones that make up our fleet. We select this one here, for instance, from EasyJet, to double-click on it. Remember, these are fake data. And you get information about the aircraft, the route, etc. Because these are our planes, then you right button, and then you send messages, you receive messages with that plane. So that is our small database. If we use ARINC to connect with it or to send data, at the end of the day, we are talking about HTTP requests. We can also take a look at the flight plans. So we get this map. By default, we get the US map. If you want to create a new flight plan, for instance, okay, let us create a route from Los Angeles to JFK. And then we choose the airline that creates a flight plan. These are the routes, different heights. And then you click on the cloud, and then you load it to the aircraft, and that's it. Okay. This is about management of the simulator, but this is not the objective of my presentation. I will try to go back to my slides. How to find security failure in aviation systems. As I told you, there are two ways: general aviation, commercial aviation, smaller and larger aircrafts. Bigger ones are more complex and better fun. Let us start off with general aviation. Often they have more simple systems, they are more affordable, they are more accessible for all of you. And it is kind of like the right part, okay, the right way to do it, especially when you are starting. Okay, let us start off with the systems developed by a company known as Garmin. Garmin does lots of GPS. This is a company saying in his blog that everything that I was doing was just nonsense and that the systems were very, very, it was not true, and that the systems were very, very safe, okay? And as I'm saying, I'm not going to show vulnerabilities. The only thing that I'm going to do is that to show you that Garmin now has a new line of business based on HackMess and CrackMess for aircraft, for vessels. You go to the website, you download them, you look for the failures, and that is a challenge. And if not, they have a serious problem, but that I leave it up to you. So Garmin, these are links to, well, different types of information. The first thing that you have to do, and especially you, I understand that most of you are not pilots, even though you may like aviation, is that first of all you need some training. You really need to start and to understand what you are going to audit. For that, I advise you to download this free software for Windows, for Mac, okay, where you have some training tools here. Imagine that you say, I want to take a look at the aviation or navigation system, okay, for that plane. You go to the website, then you download the training, and then you use it just to find out how they do it so that you learn how to handle it. And then by the time you will go down to a lower level, you will understand what they are talking about. So you also have it for PC, for Android, etc. Well, we all know how to Google things, isn't it? So first of all, you download the code of the simulator, you use it, you play around with it, and you learn it. Second, now you want the real code of that program. So that's the website to download it. And if for some reason not all the hackmechs have been published in the website, they have a program which is a web app loader, and they use it to update the things. You may download it for Windows, Macs, for PC, and then you download it and say connect the device that you want to update, and then you just download it and you update it. For some reason, or unfortunately, sometimes you don't have the device that you want to work with. If not, it's not a problem. You just open it with Radar, and then you just you just ask it to download firmware, one firmware after another. Okay, so this is the link for the program. This is not one of the most difficult jobs that you will find. And as I say, even if they do not have it in the website, you can achieve it. You can get all the hackmechs, both for the aircraft and for vessels. Okay, you have the code already. So there are different aviation systems, okay? And second, the surface of attack. We are looking for security failures here. So most of the times you will find that we are talking about files with databases, with flight plans, and many of these files are very simple. So the only thing that you have to do is just as an input, you have to use that database update or these flight plans. How do we get templates? How do we get examples for that input? Fortunately, they upload in the App Store or in the Android Store. They upload tools to do that, and then you just elaborate, you produce your flight plan. You download the application, you develop one or two flight plans, you put it in your disk, and then you do whatever you want to do with it. You use it for whatever purpose, okay? So they make it easy for us, okay? The surface of attack, it also means vector of attack. So in this case, whether it will be as easy as to use the Android device or iOS device that you may have, because they want to say, okay, let us make it easier and let us allow people to update and to load those files to devices and to do that wireless. So the smart device that you use on your day-to-day life, this is your entry door to the aviation systems of your aircraft, not only yours, but also others. So they forgot to mention that. So Bluetooth and Wi-Fi is a technology that we all know. I'm not going to go into that, and I know that well, there are people in this room who know much more than me about Bluetooth and Wi-Fi. We have the surface of attack, we have the vector of attack, and now we are going to fuzz those files just to generate several inputs and then to find our security failures. So databases, flight plans, and then we will use GDB, IDA, IDE, debugger, and well, you can use them to monitor the crashes. So here, well, we will discuss that. It's also for commercial aviation, so we will go quick now. Then we have to do reverse engineering to these files. So the firmware to find, as I say, the security failures, to see if it is a failure, if it is a crash, how you can exploit it. So we have a big file with a proprietary file from Garmin. And then there is also a link for you there. And often we find 2 or 3 images. We have the bootloader, the kernel, and the firmware, which is for the firmware, for the whole firmware. Then classic tools such as BingWalk, and then ARM. You all know it from your mobile phone. So this is like auditing any other router out there. Okay, nothing new, no technicalities, no unexpected challenges. You can start going into the security of the aviation world. Cost zero. But exploitation becomes a bit more complicated because we are talking about the world of real-time operating systems. And gets a bit complicated because they are a bit picky. Well, there is a difference between exploiting one of these, one RTOS, than Windows or Linux. My recommendation, free RTOS, which is free. There is a link around. You can read through it and you can learn it. And then Garmin has 2 variants if you want to explore it. Sometimes Garmin uses its own RTOS, sometimes it uses another one.
So we're on the right moment. We're meeting the time. Please meet the time, meet the schedule. I brought so many shell pastries for all you guys. You need to meet the standard schedule. Of course, 100% sure. We're ready. We're ready for it. No way. We're ready? Let's move on. Let's move on. Oh my goodness. You're a son of a bitch.
So
My goodness, food for free. I was collecting shell pastries around the corridors and all of a sudden I got this wonderful stuff here. Very good. This is something very positive. There's so much talk to be given. Okay, let's put some comments aside. Of course, I will get all the shell pastries back to the corridor and I will take these over from it. So systems, DPRS, Garmin Enterprise uses this so much. Okay, I can't hold it at the same time I'm speaking. Nothing's happened. Garmin, this company, Garmin uses their own proprietary operating system as well as Nucleus RTS, which shortly, you bastard. Another one. There you go. This is it. Let's move on, otherwise you'll be pissed with me. Next, real-time operating system used in the chipsets of communications. For many iPhones and iOS-based devices use it. There is plenty of documentation out there. It has a trial test. There's a trial test that takes a long time if you speak it with a very careful voice. And there's also an execution environment. You can use it. I would recommend this to you to execute it and create the very first programs and application, then to do exploitation of this operating system, which is the one you can see on Gammon. Security measures you have to cope with. Be ready, man. Execution of code? Stack protection? No, no, no. Why for it? Relocation of reading software? No, no, I'm so lazy and so on and so on. You won't find any kind of security measure on your way to this. Only the lack of knowledge of how is it working is the easiest exploitation you've ever found. Is the main logo, the main life motive of the commercial aviation. You can put it into practice. You can exploit these failures on trial. Nothing is going on. Budget zero. Inverse engineering if you want to do the radar. Here is going to be cheapest. So that the post exploitation of all this is a RTOS system with the explicit complaint. The circuit has to be on RAs. There's no shell, so you cannot do the typical self-dealing connection. By default, it does not have it. My recommendation would be to create a payload calling another on Bluetooth, and the other one gives you these cool things as managing the automatic pilot, interfering with the data of ISD for sending information, and instead of sending information over to the pilot-based devices, you can do it yourself. You can see in real time what sites such as synthetical vision and automatic pilot control and so on and so on. Garmin is giving you this to you. You can see now on the screen on the upper right image on this panel, you can see automatic flight control system, which is the automatic flight control system. The one who's telling me this is a physical switch, I can see a tactile switch this big, everything related to the automatic pilot. Automatic control the plane is implemented up software without intervention of the real human pilot. So you have a lot of playground to move around. So let's move on to this demo, which has to be a little and small one. I will continue my talk with all of you guys. We are over here, and we're over here again. No, I got it wrong. Sorry, sorry, sirs. This should be ready, but it wasn't possible. It wasn't feasible for me. So over here, let's look for our lovely simulator. I'm gonna load the Airlight and the airlines companies ratings, which is this stack, is the thing that a pilot needs to be able to fly a specific plane. That's why I call my exploits. I exploit planes. I need a special rating and a special expert to exploit these planes. This program latch in the program has the compliance things. Panky may be pissed off with this. I'm sorry. On the right is assembler and ensembler on PayRadar, which is very comfortable to do so, and the payloads, which you can see now on screen. Now you can see firmware and plane plannings and so on, which is for free on these fields. Is on the internet for free. You don't even need links for it. We take the bootloader from one of the firmware we downloaded with the hexadecimal editor. So cool. We can see where the mouse is, and we're seeing the content of the file. These are marks I put in myself because they could correspond to other files. It's for me to get the root guidance straight. So let's imagine an architecture. We select some binds, and this could be code. You know it's going to be RSM. So we can see the text chains. Some textures are rubbish, other are good. So not shell code. We have a Z compiler. You can see that is easy. It's much easy that you thought. So we are starting auditing an application like this, a software like this. So I will try to demystify something that everybody is afraid of, which is the Mr. Radare or Radare is like the man with the bag to catch him. I have my directory with all my things. Radare 2, 8, and so on and so on. Good. And this is the started file firmware downloaded with radar. Nobody is dead. No bomb exploded. This is not such a bad rule. This file, radar doesn't understand this file because it has no headers because it's a black file, but it's not harmful. It won't damage it. This is the super cool mode put by our subs users. Visual mode, your friend. This is the hexadecimal. We don't have it. We want to configure it. Packing could have done it much better because for going to configuration, you need to press the key D. It's not this difficult. So we come over here. Analysis configuration, analysis architecture x86 downstairs. I want RAM. Brilliant. Arrows moving around. I press HTM key. This system gives you arrows back and forth. We're going to SMA, and we want to work with architecture RAM. We leave it in 34 bits. We press the Q to leave it. There's the last step. Nobody's crazy here. Once we told them what file is, let's analyze it. Let's find things within. Analyze all because my guy is English speaking, so analyze. We press. It complains a little bit. It found it in visual mode. Okay. We press P to put the assembler and start reading the code. This is it. It's for free. You don't have to do anything, and it's functional, fully functional. You can start reading the code from here with the assembler. This is super cool. We can do everything our own. A big opportunity for you. With this, we achieve to be able to do inverse engineering for this code. With this, you can start. Should you be interested, you can start getting together the security plane flight. Where my respect, be careful about what you're doing and be responsible. Responsible disclosure is my recommendation. Navigation as it goes, but if you go the mischievous and bad way, please be always on the safest side regarding aviation. This is the commercial aviation is much more difficult, but this is much more fun. Let's take Honeywell as a leitmotif, an example. More information following the link. Same procedure. Training, again, first some training. These systems are much more complex systems. This is like, okay, you'll spend some time over here. What the hell, if I press this button, the fire alarm goes out. Several simulators available are not for free, by the way, not officially speaking at least. So they imply having a domain, and you can download it and use it to install it on your Windows systems. No way. But I have a Windows machine only for aviation things. It has their own manuals, and you have plenty of information to read, many links to go through the presentation. This is a normal training. Let's get the code now. So let's get because we work with code. So and now the code. So real code, not real. It's not very. I want to teach you things in a responsible way. If you want to get into this aviation world, that's why I'm here. But I won't show you to go to a place to take a box and play metal yourself with real delicate objects. Don't do that. So you got a simulator. All simulators reuse the code. They take the same code, they compile it on Windows, which is the very same code. Instead of having a physical thing, they put it a beautiful graphic interface. I do recommend that you all have to use this because a more um, easy to buy architecture. This is a familiar architecture for all of you guys. Don't do strange things, at least for now. That's my recommendation. Be always on the safe side. So high resolution graphics. Attack surface is similar to the one we saw with some more complexity. The data link, the communication protocols for aviation, and something I mentioned before, which is the remote update systems, which go through specific aviation channels or others. This emphasizes Wi-Fi, 3G, and other systems. Regarding taking templates out for doing studies, the same place uptrend, you can get them online. You can access them as iron for them for mobile applications, so on, with a link directly to the iPad applications for this kind of things. Is this easy? Fuzzing, fuzzing. So now exploitation, commercial aviation, fuzzing with. I think it's super cool. If you want to start in the smooth way, please go to the files. You can use the fuzzing software that Jose liberated something like that. You have the GitHub link is on Python. It's a very comfortable and useful interface. So let's use it. You can use database, plain plannings. On flight planning, you can use it on the Windows platform with the current debuggers you like the most: Community, DVG, CSC, RAID Array, or Windows PT. On a very, very well-known environment for inverse engineering, there is some trouble. The code, the real code within these simulators normally is in gross, is compile layer of growth without any filtering, with memory dumping, linking dynamically with the rest of it, and then any graphic interface layer programming Visual Basic and to manage it. My recommendation would be that this nucleus of real code is real toughest to apply inverse engineering because there's not much information, but the layers surrounding the graphic interface has all the symbols, little names. If you're interested in how to activate and deactivate the automatic pilot, for example, go to the beautiful layer of code. Let's find the function doing this is autopilot off, and you'll check the code, you verify the code, you don't mind what it's doing until you find another binary, and you will get the entry point for the real binary where you can find all the managing related to the automatic pilot. It's toughest, but it's easiest. So here we go. It can take us some more time. Let's put it into brackets because this goes through a virtual machine. The idea, I don't want to update you now, champion, mate. Uh, Windows XP should be started up over here. Let's give it some time. So we're gonna watch an example which is not new at all. It's difficult to find security failure or bug on the software. This is important. So we take this terminal, one more terminal, because I'm really acing the world today. On this directory, we got 4 original files from aviation existing programs, which are loaded database, which are going to be used of how difficult it is to break a program or software. We do this minus C I thought it was this flash and so on, dot and so on, and less, and we got this is a normal current file with the typical data, everyday data, numerical database, but we're gonna check now if I'm quite adept at managing the keys. There's another conceptual proof file which is real, where we can see we have substituted all the files substituted by hash. The process is blurred from this position until 1800 is full of 41, 41, 41, 41. Within this range, there are one or several vulnerabilities. I won't give you a specific object because it will take us all the funny thing. This virtual machine, the small one over here, with little software regarding aviation. This is my folder, and I start up one of these training programs for CMS, ARIN, and Honeywell training systems, one of the most extended and one of the most ancient. You can do so for the software to start off and to load the database. I'm going to do it manually. So this tells us I don't have a database, so give me one. So I created this one custom. You're gonna load it into the device for yourself. I'm not gonna give you your stuff. So are you sure? 100% sure, totally. So if it's going well, I got this mistake. I'm broken with a normal debugger and Windows application. You exploit it and you make you exploit with the exploit with very functionally for a real vulnerability which is not going to work with a real plane. Suffice it to say that tell us the mistake, the failure, and to report it. If somebody wants from on here, it wants to create real testing and trials on airlines, is good, but don't count on me for that purpose. There is no reason. It is totally unnecessary, and it's very, very irresponsible of you doing this in real planes. So we got an exploit, a vulnerability, a security failure, whose attack vector is quite realistic, because this database can be used remotely by using protocols without any kind of security. Okie dokie, you're gonna find these travel novelties within the aviation world. Is a more programming world of programming, which is by the name of ADA, ADA, to perform inverse engineering. We got an example of screen to do ADA on your computer, and then you can conduct your testing, do some other inverse engineering. It's not that difficult, but it's difficult to exploit it because it has so many protections. Then we'll see how protective and effective they are. You can see links about other compilers, links, syntax, and so on. Protections. In principle, you have protection against memory not allocated, buffers, O by 1, and all, and so on and so on. Buffer is protected against buffer for errors, range violations, off by 1 errors. I don't have time. I'm running out of time. So regarding buffer for protection, very, very lightly, very smoothly, I'll tell you that is the left green block with pink close. So the important code has been put on a separated node depending on a verification that tries to find out a buffer flow overflow has taken place. You execute IP and so on and so on. Bytes are very easy. They convert EAX. If it's a negative number, this is the exit for the function that immediately appears on the upper part, where we try to verify if there is a real overflow of data. And you will see the functions this into detail later on with the slides. Stack protection, basically, this means if you pay attention what the flow of the program, the functional structure has not been altered at all. Very firstly, it keeps some values in the stack, and it does many things. It takes them back, and it does several things to check if these values are valid or not. I cannot go into detail why I can't go into detail, because all these checks can be disabled in the interest of runtime efficiency. So we got them, but you are gonna find them. So that are over there. You can find them. You know how to recognize them. And here we go. But I'm not, I couldn't care down about this. Regarding VxWorks, this is the realm where everything is executing. When you have to fight to make the right exploitation of this version, VxWorks is will host 80 to 100 applications. This is one of the most useful ones. It has so many variants, and it's very useful in aviation. It's quite a specific. My recommendation would be to go to the website of the creator of WXWorks, and by using this link, you'll download this DVD ISO image to compile program to have an emulator to start up. You can mount it and set it up on a virtual machine. Zero cost is trial, but if you ask it with a very agreeable tone, you'll get it from him with no problem. I will use it. I will recommend you to use it as an entry platform for what is being commercial aviation. These are big words, by the way. Here we're gonna stop a little bit. Sorry, because I noticed you are slightly. This is technically heavy going issue. So RTOS, you execute the program you like, you close it, and you do whatever you like. With RTOS is infinite buccal mode is starting out pretty fine. Tags which are listening to you forever in the wait of events. When event 1 executes tags 1 period, and so on and so on. I wasn't. So this can be done with more multitasking programming. So there are many tags, and all of them are doing the same. They're start listening to, and it asks for their turn. The operating system gives their way to that, and period. How can we create these tasks? In the case of Ubix's X, we have lag stuff. You send over these parameters in red, which is a stack. Pay attention to the stack in red on screen. If you have this level of control regarding what you're writing down, you have entry. You can specify the entry point for every task. I leave it over there, not because of the tasks you can program, but because of the ones you can find. Regarding the tasks, there is a link, the stack, in which the TCB, tax control block, where you can link different tags all together in there. And if you are new in the office, what tags are over here? So you go into the TCB, it's a data structure which contains information about the tax content. It's available for all of you guys. Should you use this slide sometime. In VxWorks, there is no protection against a stack overflow, little security. There is a security measure which what is done is it fill in the stack with characters XL when executing these stacks, and then is verifying the level of usage of this stack with the function, which go through until finds what it's looking for. Secure. It's not a very secure measure, but it's thought of not from a security viewpoint, but for a safety viewpoint. It's not conceived to fight somebody who tried to jump this system. Like I said, people may find it silliness, but it is a very time-consuming system on an RTO system. So I'm going to deactivate it because it can damage me. This is regarding exploitation, RTS, and these are more dull things. But the coolest part is the post-exploitation, where we're going to introduce a new concept, something novelty, which is the concept of integrated modular avionics, CC Common Core System. It's called as, by Boeing, like CCS, Common Core System. Let's detail this later on. Traditionally speaking, this was the lookalike of the guts of the aviation system on a plane. Many computers interconnected and wired by many optics. The industry has made as follows. A very same computer has a huge load of these systems by using a standard called a ring 653 RTOs, connected with a standard communication system, which is Ethernet, like the network. This is a visual example. This is a plane. We have many boxes all around the plane compiling information wired by this thing. This is the Ethernet. And then we have two boxes on the front, which are duplicated due to security measures, which are the big hangs of computers, contain all the aviation systems as very good friends. So all this information from these two main computers moved towards the pilot and to be executed with the commands on their rocket pit. So this seems less chaotic, but it has its own logic. To what extent is this secure? Because, oh my goodness, so many things condensed in one single big computer. For us to conduct this kind of technology, the aviation world has come out with a new standard, the RN 653 APEX, used for operating systems running these processes, RTOS systems, and having and define with their own standard for the APs. The uses POSIX, they call apex in English, and I don't think there are this big difference. Basically, it defines a series of categories of apex between you can do partitions processes in a well-managed way. Critical RTOS, the communication in between, and it's used for managing memory. So I have to say, no apex services are provided for memory management. He corrects himself. This is the table. We change the name of things. On POSIX is you're working on cyclical ways. We have processes, partitions. Okay, APEX means cyclic base, partitions, processes, spatial partitioning, APEX. This is it. You know APEX. The one who wants a seal of APEX domain is all you need. Cyclic basics, partitions, processes, and spatial partition. And they only change the names of the APEX. A partition with 7 processes, I have a processes with 5 threads. This is the mental translation you have to do to understand this. This is it. You'll tell me, okay, well, what the fuck is going on here? This is regarding exploitation by exploitation. How can I use it? And that's why I'm here. So we need a testing environment to test our post-exploitation on these environments. Nothing is going on. For this purpose, we're getting an operating system compatible with RN 653 on open source, which is called POC. POKRTOS, which can be downloaded and be tested on your trials. It's compatible with the standard, which means it's compatible with the standard. Please don't fool you around this because there is no difference at all. But let's turn it around. If somebody is listening around this to compile about all these things, aviation industry people gave a twist on a project which is free for everybody, and they mounted a virtual machine that the taster tasted TASD, which can refine programs, applicate all the software code for this kind of IMA environments. It's a virtual machine available for you guys. IMN software development toolchain. You'll get the compilers and all the stuff necessary for this purpose. There are no trouble at all. I have a wonderful virtual demo. I will skip it. For example, you're telling me I'm gonna download this virtual machine and creating a Vonix program to be exported later, and this is gonna take me 1 year. It will be true, but thank God we got a very long list type of codes where you can execute this code and you got a functioning automatic pilot partitioning of several times. You'll get in the right code, so you can modify it and to introduce a little vulnerability. In the meantime, you can practice exploitation and post exploitation. You don't need to learn how to learn the whole stuff. I'm 5 minutes behind the schedule. So one case study. This is about to finish, and my head presentation is about to finish. So if want to make a payload super cool for exploiting these environments, this could be this could think of meter Peter. The meter Peter is not useful. We need to use the POSIX meter Peter, which is used for this purpose. It's not a POSIX, it's Apex, so things get messy here. So you have to create an Apex meter Peter where we put everything. So I created my Apex Simon. This is the coolest thing I've ever come out with. So it's much better, and I'm now meeting Simon, which is the payload advanced for this purpose, so specifically for this the latest release for this kind of environment. So this is sum up information of the main characteristics is a static shell code with their own RTLD to load libs. Avoid using local libs as well. Is a one stitch loads to loads and maps in memory and so on and so on, as you can read on screen. Is an adaptation to a beautiful world. There's a very interesting talk about how they migrated to Linux, and I want to apply the Simon thing to our TOS. Let's see the internal function of how to do a payload advanced for this. So if any syscalls you can need is open core, you'll get here kernel include core syscall.h. Therefore, this is standard. This is applicable to all other environments. Let's start the Simon story. Simon is a freaking bad guy, suffering a lot. He's in an unknown world or environment. Simon says to us, we own the FMS. You send me to FMS. So what else or who else is around here? So Simon, first we need to. How many other partitions are around? This is the main thing. For this purpose, Simon uses calls to these Apex specifically. What partition do I have here? What else? What other partitions can we find? And this way, by using these calls, Simon, my goodness, I sneaking in. Simon, firstly, Simon does not look for friends. Simon wants to locate himself. He's on an FMS. He has not much idea about. So he needs to learn about the information of their own partition, partition process. And he knows that is a partition on a AMI system, and he's on an Apex text environment. I feel so lonely over here, and he tries to communicate with the rest of the partitions. So he activates this series of calls to find out what other partitions are over there, if there is somebody outside there waiting for him. So Simon finds other partitions, which means that he knows how to expand himself to other worlds, because the world is bigger. So he wants to communicate with the rest of the partitions. For this purpose, the standard developers created buffers, backboards, and ports. I won't explain ports to you because everybody knows what a port is. Blackboard is a shared memory space to store data. partitions can write and read over there. They can exchange information. And the buffer is a thread send data. It's a direct communication between two partitions by using a port. Some APIs will be used there for managing these things. And with this, you can find out what partitions are moving through, and you can communicate with them by using this. And by coming back to use the previous information for our own partition, we can extract information from the rest of other partitions and communicate ourselves with them. And if one of these partitions is put in a different code for suffering a vulnerability, we warn some about this, and we expand our presence within the system, which is one of the advantages of us of having up to 100 processes and systems on the same computer. You don't have any trouble communicating with them. Nonetheless, may I communicate myself with other modules or computers like this? Of course you can, but I don't. I'm running out of time because Roman, the organizer, is telling me that this the end. You'll get the links on screen with this AP and this programming thing. So you can create your own Simon for playing around and meddling with partition. You can create two vulnerable partitions. You can vulnerate them, and this is it. This is very easy. What kind of things can we do? No physical circuit breakers. I have nothing to add. So you get it at home. Okay, planes also have circuit breakers to interrupt, activate, deactivate, because now, as you can see on screen, this is a tactile screen within a computer and is a very close partition to the one you are controlling. Just a short list of available partitions for information. These partitions are the most common for the aviation systems adjacent to the ones you're using. I am afraid that this is the end of my presentation. It was a heavy presentation, but this is it. This is about finding and exploiting security errors and mistakes on aviation and defense aviations. So now the bonus part is for all you guys. Bonus now is left for me is a bonus. It's a project I started 7 or 8 months ago. It's not this advanced as I would like it because I have some job issues. This make me be very busy. I'm coming back to it. Bonus is it stands for AS, Aviation Security Handbook, which is I'm putting all of this, all the info I'm getting and collecting over these past 7 years on one single security aviation book. Security, not safety. Be careful about this term. It's not the commercial buy my book when I'm leaving the road because it's very expensive. This book is going to be free for all the guys since the very beginning, since the very first beginning of their publishing. I'm wrapping up. The objective of this book is twofold. People like you, having the technical expertise, the technical knowledge, but not the aviation knowledge, can resort to this book to find the answer of your questions, because you may be messy with this, the things I told you. So I will explain to you with detailed information all these things on this computer, even though because you don't want to be aeronautical engineers, you want to understand the software for aviation, period. These are aviation concepts. Part 1, Part 2, especially for aviation people knowing about aeronautical knowledge, but not technical knowledge about from a security viewpoint. These people can resort to this second part to complement their knowledge, especially those interested, and they can use this book as a reinforcement, as a big support to be framed and situated on security aviation purposes. Of course, with on the first side, this would be for free for you guys on PDF, on website. I may print it out on paper, but in that very case you have to pay for it because it's expensive to print it out on paper. In that case you have to pay for it, but it may cost at around 6-7 euros. I don't know how much cost to binding, to print it out, everything. This is it. There won't be demo time. I'm sorry, I'm running out of time. I wanna give you a gift, a present to my people. Okay, so far so good.
Lo del patrocinador cojonudo, pero que nadie se lleve un duro.
Oh, our sponsor is good, but there will not be any middleman in between to get money from it. I'm running out of time. I don't have time to present this demo. The idea is you spend some money to come to this congress, or you got somebody to pay you for coming here in exclusivity. So I got a gift, a present for you guys. If you wanna share it with the rest, it's up to you. There won't be pictures on this slide. You can do it on your own. And I'm gonna give. Do you think I'm gonna give you access to all the chapters? You can see it in a privileged way. You will have privileged access to all my private chapters. You don't have to wait for more time for me to publish it. I got a website which is not currently working, and an email list where in the next coming month I will be making you notice about the state of the art of this project. So I will show later for you to see all the pictures. Don't worry. My friends, I will now will take over from me. Now is your option. This server is on holiday. Don't worry. Don't worry about me because I'm going on a plane, but I'm coming back on a boat. Thank you very much.
No me pasa mucho, ¿no?
I didn't exceed my time. It's up to you. If you want to pose over 2 questions, those of you who want to pose over 2 questions, raise your hands, pack them off. I got a question. Should I have any questions? One question. You have to be back at 4 p.m. Everybody back at 4 p.m. Thank you. Questions for Hugo? I have a question for you, Hugo. Can you come out with something to enable working group to penetrating this closed environment? This industry is quite close, not dynamical, penetrating thing. They have their own communities. There's a very close environment. They're not going to consent us into accessing. No, intruders will be accepted inside. We're sorry. An anecdote. I'm going on stage with you. I gave a talk at an event, and I mentioned the Spanish talent, special talented individuals from Spain. I mentioned Hugo, having such a talented man, Hugo, how can we pay only 18,000 euros, shitty 18 euros to these people? And when I left the room, at the door, he told me, I belong to this organization. I don't know how can you explain about this fucking liar Hugo who is telling stories, freaking stories. I think you don't know who you are. I am one of the organizers of the event where Hugo Teso spoke. So this guy stepped back and he blushed. I'm paying for Rooted.com. Rooted.com is coming. I'm paying for his trip ticket, his materials, and these are the demo rules. I'm paying for all of it. So if the demo is a lie, I will be in public. In the next Rooted.com, Hugo, you are a fucking liar, and I will sign it with my own hands. If it's true, and we can prove the room to be real, we won't give any more news. The talk is given, the status won't change. machines. I send them an email with my key DP and raise your hand. Do you think we have the one who think we made the demo? Raise your hands, please. Those one who think that those demos won't ever be done. That was the answer to this security obscurity. So, my friends, time for lunch.